Okay, so the last time we were together, you would have been exposed to last year's paper one. I'm reminding you of it. Again, I'm not going to go through the entire question or paper, but I'm just going to pick out one or two that gave you some challenges. And also, I'm also going to make a few comments. Is that Bernica in the room? Good morning, Bernica. How are you today?
She's logging in. Oh, there she
Okay.
is.
Okay. With the number operators, add, subtract, multiply, and divide, I just want to caution you to be careful. Most of you handle them well, but in a few cases, you just made a few careless mistakes, adding incorrectly or regrouping. And the division, you want to watch out for zeros. A zero was included there, so just be careful there. Okay, most of you were able to handle the ratio. The substitution, you did well. Remember, the symbol means the square root. So it's the square root of all of the values under that symbol. Some of you just worked out the values and then you did not find the square root. So you want to make sure that you apply the roots to your result. Now, here's a question that gave some of you challenges, and I'll go through number 6. Using pi as the fraction 22 over 7, or 22 sevenths, calculate the perimeter of the circle. Now, I want to hear from you, but perimeter, when we talk about other shapes, we use the word perimeter. But as it relates to the circle, we don't refer to the perimeter. What do we reference when we talk about the circle? Anyone remembers that term? It means the same as perimeter, but what do we call it?
The circumference.
The circumference. So you needed to, very good. So you needed to be able to recall the formula for calculating the circumference of a circle. Now remember, the exam will not give you the formula. You have to commit it to memory. So help me out. C for circumference, what is that formula? And in fact, you might have been exposed to two formulae. First of all, let's review the circle very quickly. So this is the circumference, the line going through from one end of the circumference, passing through the center, extending to the opposite end of the circumference. What do we call this line or line segment? Okay, you should remember that that's your diameter, D for diameter. If the diameter is 14 meters, then there's a relationship between diameter and the line segment that starts at the center and extends to any point on the circumference. That's your radius. The radius is half of the diameter. So radius in this case is 7 meters. Now, why am I giving you both? Because it depends on the drawing. If you're given a drawing that has diameter, then the formula that you're going to use is pi d, or pi times d. For emphasis, I'll put in the multiplication symbol. We know we don't need it. And then the alternate formula, anyone remembers that alternate formula? If you're given a drawing where radius is given, not diameter, but radius, what's that alternate formula?
C equals pi times r squared.
Well, that's actually the formula for the area.
Oh.
So area of a circle is equal to pi times r squared. So this question is not asking about area, but it's asking about perimeter or circumference. If you remember that the diameter is made up of 2 radii, we can take this formula, I'm going to put pi in the middle, and split diameter into 2 radii. Watch for it. 2. 2. And here's my 2 radii. 2. I'm going to go ahead and put in the multiplication only for emphasis. I can write this as 2 pi r. You know that in algebra we don't use the multiplication symbol between our terms. Okay, so if in doubt, just think of the diameter being split into 2 radii. So the alternate formula would be 2 pi r. So you were given diameter, so you're going to use the formula that contains diameter. And so pi is given as 22 over 7. We're going to substitute. 22 sevenths multiplied by diameters given 14 meters. 14 is a whole number, so we're going to put that over 1. Now to follow through, we're going to cancel 7 into 7 once and into 14 twice. How do we multiply fractions? We multiply the numerators, 22 multiplied by 2 in the numerator, and then we're going to multiply the denominators, 1 times 1, and final answer 44 over 1, which is the same as 44, and the unit is meters. Perimeter or circumference is not written in squared units, so it's simply m, not m to the power of 2. Any questions on that? Okay, so again, to determine the circumference of a circle, you have two choices. If diameter is given, the formula is pi times diameter. If radius is given, the formula is 2 pi r. Okay, don't confuse radius with, don't confuse the circumference formula with the area formula. Now, we went through this particular dissection before the test, so I'm not going to go through that, only looking at where you had some challenges. Okay, the fraction question was done fairly well, but for emphasis, let's just go and look at this one, and then we'll move on. So, if you look at part A, I see fractions contained in a bracket, and that's an addition symbol. So you have to recall, and incidentally, the operator in the brackets is multiplication. So you have to recall the rules for multiplying fractions and then the rules for adding. We're going to start with the brackets. How do we multiply fractions? First of all, we look for ways to cancel. We can cancel in this case. So we're going to multiply numerators. 1 times 2 gives 2. And then we're going to multiply denominators. 5 times 5 gives 25. So we're done with the brackets. To that, we're going to add 1 and 11 25ths. Now, when you're adding, you can examine your denominators. If they are like, then we can add quickly. Okay, we have a proper fraction, and to that we're adding a mixed fraction. So the easiest approach would be to deal with the whole numbers. We only have 1, so 1 becomes the whole number we will use in the answer. When denominators are the same, we keep that same like denominator. And now let's examine the numerators. 2 plus 11, 13. So your final answer, you cannot simplify that further. Final answer, 1 and 13 25ths. Okay, so we ran into a little bit of problems with the division. Remember, when you're dividing, if you're starting or if you're given a mixed fraction, convert first to improper. 2 1/3 is improper. How do we do that? Anyone? Really quick. What's 2 1/3 as improper? 3 seconds. That would be 7/3, yes? Why? 3 times 2, 6. 6 plus 1, 7. And we keep the denominator. And then I'm just going to bring down the second fraction, divided by 21 24ths. Now, recall the rules for dividing fractions. How do we divide fractions? I'm going to put it over here. 7/3. We're going to keep the first fraction. Let me just use the separator. When we're dividing, we change the sign to multiplication and we invert the second fraction. So 21 24ths becomes 24 over 21. Now we're using the follow-through rules for multiplication. Cancel 7 into 21 3 times. We can also cancel in this direction, dividing by 3, 3 into 3 once, and into 24 8 times. Okay, if it gets too busy, I like to circle what I'm left with. and that tells me what I'm multiplying. So in the numerator, 1 times 8 is 8, and in the denominator, 1 times 3 is 3. Now, some of you stopped here, but remember, you always want to, in your answer, take the improper fraction and convert it to mixed, and you do that through division. 8/3 literally means 8 divided by 3. How many times does 3 go into 8? 2 times. What's the remainder? 2. And we keep the same denominator. Okay? So we want all the points. We want to make sure that we follow through. Okay, any questions? If you do need me to go through in more details any of the questions from your paper, I still have it saved on live worksheet. So if you'd like for me to go through it with you, then we can do that. Now today is going to be an algebra overview. I'm going to be doing a loaded overview of algebra. So the final thing I want to do from the B.J.C paper is look at the algebra questions. Okay, so this is what you had to do a few weeks ago. And the verb in part A, simplify. Okay, if you look at this expression, I see 5g plus 3, open brackets, 2f, take away 3, close brackets. Can anyone assist with this? What would you do first? No one? It was that long enough ago? Well, the first thing we're going to do is we're going to get rid of our brackets, and we're going to use the distributive property to do that. Okay, so we're going to keep the 5g plus. Now, let's get rid of the brackets. So what does the distributive property say? And we're looking at this portion here. It says that we're going to examine the term on the outside of the bracket. And if you look on the inside, we can call this a group. What's in our group? I see a 2f, take away g. So I see 2 terms on the inside, 2 terms in this group. We're going to multiply the term on the outside by each term in the bracket. So I like to use arrows to do that. So I'm going to multiply 3 times 2f. So 3 times 2f. Hopefully you recall the rules of multiplying. Multiply the coefficients. 3 times 2 is 6. And the variable f. So 3 times 2f gives me 6f. But we're not done. So we're going to go back and we're going to multiply the term on the outside by the second term on the inside of the brackets, paying attention to the sign. So 3, you can technically think of it as a negative g. 3 times negative g, so the sign is going to be a minus 3g. Now, we've removed the brackets, but we are not done with simplifying. How do we simplify? We simplify by collecting the like terms. So if I look at the terms 5g, 6f, and 3g, hopefully it's obvious that my like terms are the 5g and the 3g, and we carry the sign with the term. It's often helpful to rearrange, giving you 5g, take away 3g, plus 6f. Once you've rearranged or collected the like terms, now you can look at your groupings. So let's examine the groupings of g's, where the variable is g. 5g take away 3g gives me 2g, so I'm going to use 2g in my answer. And the second part of this expression, the only thing it has in common is itself, so that also goes in my answer. Final answer, 2g plus 6f. Most of you did pretty well with this portion, but factorizing gave you some challenges. In fact, I don't think anyone got this. We're going to talk about this in greater detail. Think of the word factorize. At the root, I hear the word factor. Okay? If I gave you a number, like the number 12, and ask you for the factors of 12, you would probably give them back to me in pairs similar to this. You would say that 1 times 12 are factors of 12 because when we multiply these two numbers together, they give us 12. Another pair of factors would be 2 times 6. And again, for the same reason, 3 times 4. So we can multiply factors together to get the original number. The same thing happens here when we factorize algebraic terms in an expression. We're looking for, first of all, we're looking for a term that is common to both, or factor, sorry, that is common to both terms. Okay, so I have 12a as the first term in this expression, and then I have 8ab as the second term in this expression. So let's look at these two. 12 is the coefficient, a is the variable in the first term. Second term, 8 is the coefficient. A is a common variable, but the second term also has a variable b. So what you would want to do is you'd want to think of each of these. I'll use columns. Let's see if that is helpful. Each of these columns, and try to figure out what is the highest common factor or the largest number that can go into each number in the column. So starting with the coefficients 12 and 8, I can see that the largest number that can go both into 12 and 8 is the number 4. I'm going to use that. Now I look at the second column, A. A is common to both terms, so A is the highest common factor. If I look at the third column, there's a B. That's a part of the second term, but B is not a part of the first term, so B is not a common factor. So what am I going to do with the highest common factor that I pulled out of the two terms? I'm going to use those to factorize my expression. And I'm going to do it in the same way that we did over here in the margin using the factors of 12. I'm going to multiply the highest common factor by the number that's going to give me my original expression, or by the term that will give me my original expression. What do I mean by that? First of all, instead of using the multiplication symbol, I'm going to use brackets. So if I look at my original expression, I had two parts or two terms. I want two terms in the brackets also. The terms are separated by addition, so you're going to see that happening here also. Now, for the first term, how do I determine what to multiply 4a by to get 12a? Technically, what you're doing is you're taking the term 12a, and you're dividing it by the HCF. And when you would have practiced enough of these, you would find that it's super easy. You can almost do these mentally. 12a divided by 4a is going to give me, let's do it slowly, 12 divided by 4 is 3. Or you can say they cancel, and the a's are gone. The a's cancel. So it's simply 3. So 4a times 3 gives me 12a. Okay? Now let's look at the second term. What can I multiply 4a by to give me 8ab? Let's go ahead and do the same thing. Start with the 8ab and divide it by the 4a. So we're just going to do the opposite. 8 divided by 4 gives me 2. A's cancel, but I have b. So 4a multiplied by 2b gives me 2ab. So I have factorized this expression. I've pulled out the common factor, and then in the brackets, I've come up with the factor that I need to multiply by to give my original expression. Okay? I went pretty quickly there, but hopefully you would have understood at least a part of it. Now, this is an equation. We know it's an equation because we see an equal sign. There it is. The equal sign divides our equation into two parts. A left-hand side, LHS for left-hand side, and a right-hand side, RHS for right-hand side. The goal of any equation is to solve. You have some unknown, some variable, and the goal is to solve. So if I look at this equation, 3h plus 4 equals 13. Here's how I would think. 3 times what number plus 4 is equal to 13. So I'm trying to solve for h. Now, I'm going to use the algebraic method. Some of you might have been exposed to another method. Hopefully I won't throw you. The algebraic method says we undo the number operator that is along with the variable. We're going to undo by doing the opposite. So if I look at this expression, if I look at the left-hand side where my variable is 3h plus 4, what's being done to the h term? 4 is being added to it. So let's undo that. If 4 is being added, the way we undo, we do the inverse. We perform the inverse or the opposite operation. Opposite of addition is subtraction. Additionally, the rule says that what you do to the left-hand side, you need to do to the right-hand side. So if I take 4 from the left-hand side, I'm going to take 4 also from the right-hand side. Now watch the follow-through. My 4's cancel, leaving me with what? Leaving me with 3h on the left-hand side. Bring down the equal sign. And then I'm going to solve 13 take away 4. 13 take away 4 gives me 9, but I still don't know what h is. I have 3h now being equal to 9. So now I'm not done. I'm going to move this up here. So I'm going to follow through here. 3h being equal to 9. Remember your goal. My goal is to solve for h, just h by itself. Again, using the algebraic rule, I'm going to undo what is being applied to h. 3h means that h is being multiplied by 3. So I'm going to do the opposite of multiplication. That's division. I'm going to divide by 3. And if I divide by 3 on the left-hand side, I have to divide by 3 on the right-hand side. I have to perform the same operation. Now let's follow through. The 3's cancel, leaving me with h. Bring down the equal sign. 9 divided by 3 gives me 3. So now I know what h is. H is equal to 3. I have solved for h. I can test my solution. I can go back to the original equation. 3h plus 4 is equal to 13. This is the original equation, and I'm checking it. And I can substitute my answer into that equation. If my answer says that h is equal to 3, I'm going to substitute h with 3. And what do I expect to happen? I expect that the solution will work out to be 12. So let's check that. 3 times 3 is 9. 9 plus 4 is not 12. So what did we do wrong? Does anyone spot my answer, my error? 9 plus 4 is not 12. What did we do wrong? Oh, I see what I did wrong. I wrote 12 and this should have been 13. Okay, and that's what you want to do. You want to make sure that you can spot any potential errors. So 9 plus 4 is 13, and my solution is correct. Okay? All right, you guys are quiet on me. I need to hear from you. All right, so that was your exam paper, and those were the key areas that troubled you. This was the 2020 paper 1. Any questions on that? We're going to move on to what we want to talk about today. Pranika, you good? Caleb, any questions? Jenny, Romardo, Terrence?
No questions.
Okay, so let's go into now our algebra review. And I told Ms. Naki I'm going to try to be very adventurous today. I'm going to try to go through the entire algebra